So have you ever wondered what exactly goes into a highly engineered, high-retention educational explainer? I mean, we're not just talking about someone turning on a camera and talking about physics here. No, today we are decoding a secret language. It's this fascinating intersection of intense viewer psychology and strict academic rigor. We're going to look at the actual source blueprint used to build these hyper-optimized educational tools right from the ground up.
Okay, let's dive into this. Here's our roadmap for today. First, we'll dissect the ultimate script blueprint, move right into engineering high viewer retention, explore injecting core physics concepts, decode the maths grid, and finally, look at building the binge loop.
Section 1. The ultimate script blueprint.
This foundational blueprint we're analyzing isn't for an amateur. It is specifically designed for an elite YouTube scriptwriter and content systems engineer targeting the Cambridge IGCSE Physics 0625 syllabus. So the stakes are incredibly high and every single second is meticulously calculated. This brings us to a core strategy they call the 1-minute rescue, which is part of what the blueprint refers to as a rubric decoder. Forget long, rambling introductions. The prompt dictates zero greeting and absolutely zero fluff. The entire goal is to grab a student's attention by showing them a painful, familiar mistake within the first 3 seconds and then promise to save that failing answer in exactly 60 seconds. It creates an instant spike in stakes, marks lost, grade boundaries at risk, or just a sudden shock to their confidence.
Section 2. Engineering higher viewer retention. Now, this is where the mechanics of attention really take over. So let's pick up the tempo a bit to mirror the strict, urgent pacing of these rules. Just look at this rigidly mapped timeline. At 0 seconds, you have a 15-second hyperhook. Fast forward to minute 13, boom, an interactive viewer challenge, and by 16:30, an examiner-style correction. But the absolute linchpin happens at exactly 4 minutes, the fresh, open loop. The source actually dictates that at minute 4, the script must make viewers feel that leaving right then means missing the single most important examiner clue. It's literally designed to lock the viewer into the rest of the explainer.
And to keep them locked in, the blueprint demands rapid visual pattern interrupts, B-roll, kinetic typography, red pen annotation, timer overlays, zoom punch-ins, sound stingers, quick quiz cards. The prompt requires a brand new visual trick every 4 seconds. Seriously, every single 4-second beat from 0 to 20 minutes must interrupt the viewer's visual pattern so their brain simply doesn't even have the opportunity to get bored or click away.
Section 3. Injecting core physics concepts.
Okay, let's take a breath and slow down our pace for a moment here. Because all those flashy retention tricks, they're completely meaningless without a rigorous academic payload. For this specific blueprint, the payload is focused on the electromagnetic induction chapter, specifically mastering generators, transformers, induced DMF, and the national grid. To deliver this, the script teaches a very specific 4-step framework to build the perfect physics response. First, identify the concept. Second, pull in the evidence or data. Third, apply scientific reasoning. And fourth, wrap it all up in precise examiner wording. As the explainer progresses, the prompt mandates that the stakes rise every 2 minutes, pushing the student from quick wins into much harder, high-mark Cambridge-style examples using this exact framework.
And this brilliantly illustrates the strategy. This side-by-side contrast is exactly how they drive the point home. On the left, we see the painful, flawed student answer, plagued with missing units, early rounding, and just vague explanations. You know, it's the kind of mistake ordinary revision doesn't fix. But on the right, we have the improved top band answer, showcasing correct terminology, substituted values, and proper units. Seeing this side-by-side comparison is exactly what forces that aha moment for the student.
Section 4. Decoding the maths grid. Now, what's really interesting about this slide is that to actually fix those flawed answers, the student needs hard, actionable mathematical skills applied to physics. The blueprint insists on using this exact uncompressed source material, the IGCSE Physics Math Skills Grid. It explicitly states that diagrams, tables, and in this case the skills grid, shouldn't be compressed, making sure every single detail is crystal clear. The strategy leverages this grid directly to identify exactly where a student's math is failing their physics. Let's see how this builds into actionable advice.
By pulling directly from that grid, the blueprint outlines the essential maths fixes required to save a failing answer. The student absolutely has to master choosing the correct units, determining significant figures, plotting points accurately on a graph, and extracting data from curves. These specific skills are what prevent those incredibly common errors, like graph axis mistakes or completely blowing a calculation because of missing units in a transformer equation.
Section 5. Building the binge loop.
All right, this is where the content systems engineer hat is firmly placed on the scriptwriter's head. The goal isn't just to teach one single lesson. It's to psychologically trap the viewer into an endless cycle of learning. The prompt requires a carefully formatted 20-second end screen layout. It features the next explainer on the left, a subscribe button on the right, lower third text, and a progress arrow. And get this, the scriptwriter is legally bound by the prompt to include this exact mandatory call to action exactly once. Subscribe to our YouTube channel Ace the Exams, at @acetheexams_IGCSE to excel in your Cambridge examinations. The next topic isn't framed as an option. It is framed as a mandatory next step to survive the exam.
Which leaves us with this final masterstroke requirement from the blueprint. It demands that the writer identify an unresolved problem or a fresh curiosity gap left at the very end of the explainer. Something that absolutely requires watching the next part of the series. It makes you wonder, doesn't it? What unresolved problem could they possibly leave hanging after 20 minutes of intense physics strategy? Well, I suppose to find out how they close that gap, you just have to watch the next explainer.